In this video, we're talking again about how to evaluate an equation when we have functional notation. So in this first example, we have the function f of x is equal to x squared plus x plus 1. We know this is a function because we have this functional notation on the left-hand side here, f of x instead of just y. What we've been asked to do is find the value of the function when we plug in a squared for x. And we can see that because you can see that we have this f of a squared is similar to this f of x here, and drilling in deeper we have a squared right in this position with x. So this basically tells us plug a squared in for x everywhere over here on the right hand side, and then simplify to get the value of the function when x is equal to a squared. So we're going to say f of a squared, and then just plug a squared into the right hand side everywhere where we have an x. So we're going to get a squared squared plus a squared plus 1. A squared squared is a to the fourth plus a squared plus 1. Let's look at another example that's a little bit more complicated, but again, exactly the same idea. We've been asked to plug 1 over AB in for theta, and the purpose of doing this second example is just to illustrate that it doesn't matter what we have here, and it doesn't matter what kind of variable we have here. The point is that when we say find g of 1 over a plus b, and we've been given a function g of theta, we're just plugging 1 over a plus b in for theta. That's what functional notation tells us to do. So when we do that here, we're going to say g of 1 over a plus b, like this, and then we have to plug 1 over a plus b in for theta. So we're going to get 3 over 1 over a plus b squared, because we have theta squared here. When we square 1 over a plus b, that's the same as saying 1 over a plus b times 1 over a plus b. We have two factors of 1 over a plus b. Multiplying these fractions together, we multiply across directly, and we'll go up here and say g of 1 over a plus b is equal to 3 over, and then here 1 times 1 gives us 1, and then a plus b times a plus b we can just say is quantity a plus b squared, and we could have FOILed it out, but we can just leave it like this for now. Then essentially we have 3 over 1 divided by 1 over quantity a plus b squared. So instead of dividing this fraction by the other fraction, remember the rules of fractions tell us that we can multiply by the reciprocal of the denominator instead of dividing. So instead of 3 over 1 divided by this fraction, we'll say 3 over 1 multiplied by the reciprocal of the fraction. So we flip it upside down and say quantity a plus b squared over 1. Now we're multiplying fractions, so when we multiply our numerators together, we're going to get 3 times quantity a plus b squared. When we multiply our denominators together, we're just going to get 1. We don't have to write this whole thing over 1. That's just redundant. That's understood that this is over 1. So then the answer is just 3 times quantity a plus b squared. If we want to, we can FOIL this out. You would get 3 times a squared plus 2ab plus b squared. If you did that, then you could, if you wanted to, distribute the 3 and get 3a squared plus 6ab plus 3b squared. All of these here are equivalent values, so they all equal the same thing. I think it's cleanest to just leave it factored this way instead of writing it out like this as a polynomial. Either way, the point is that g of 1 over a plus b when g of theta is given by this function here is going to be equal to 3 times the quantity a plus b squared.